organization, but then, and it's not just a technical operators who's willing, who has the knowledge and willing to deploy, but you need key business decision makers to agree that they can start their V6 to be commercially ready. There may be a role where government can play in creating an environment that would encourage V6 adoption in their local country or like in a smaller area. And so there are various players that you actually need for the internet as a whole to be V6 ready. And I think IGF is the perfect platform to have this kind of discussions where we have different players, different stakeholders joining the meeting so that we can discuss what would be the role of different stakeholders can play in encouraging the V6 deployment. So that's the basic introduction. And actually in the global discussions, since last year, from 2015, what's called the Best Practices Forum on this theme has started, exactly for the reasons that I've shared. And we have actually produced a document that describes what are the collecting the case studies of government measures from different parts of the world that has encouraged V6 deployment, or V6 task force initiatives in different, again, like parts of the world, or what are the lessons learned from private sectors. So that was one output document that was produced in 2015. If you go to the global IGF website and click on the Best Practices Forum IPv6, you can actually confirm this output document from last year. And also this year, in 2016, there's continued work on this theme at the global IGF. But building on last year's work, the focus this year is to study what is the economic element in encouraging V6 deployment, both in terms of looking at it in a bigger picture of how would V6 deployment help in a more development for the ICT industry as a whole, as well as individual business cases for the industry players. So that's what's happening for this year, and we started collecting case studies from different regions. So the cases from our region, the Asia Pacific region, is strongly encouraged, and anyone is welcome to make a contribution. With this, at this session today, I really would like to focus the perspective from the Asia Pacific region, and I've invited a panel of speakers sitting on my side. And so I'd like to start first from Paul Wilson from APNIC, who would give give us a view on why is it important for the internet to be V6 ready. So Paul, would you be able to give a brief 3 minutes introduction on your view on?
Sure, of course. So to introduce myself, I'm Paul Wilson, the head of APNIC. APNIC is the IP Address Registry for Asia Pacific, one of 5 different organisations that exists around the world. It's not non-profit membership organisations with the responsibility to manage and distribute IP addresses, IPv4 and IPv6 addresses in our region. Excuse me. So we're very interested in IPv6. We take our guidance from APNIC members, and APNIC members have stressed that they want us to help with IPv6, to help to get our region deploying IPv6. Now, what's the reason? Well, the reason's pretty simple. The early architecture of the internet specified internet addresses, specified a numeric address that was to be used by every device, and every device under that model should have one single unique address for every device on the internet, and that allows those devices to be reached. It allows global connectivity from device to device wherever they are on the internet. So that was actually a very powerful thing at the time, and it's one reason, excuse me, it's one reason for the internet's great success, the fact that it had this global addressing system. But the IP system, IP protocol that was introduced at the time, IPv4, was introduced in 1983, and it allows a total of 4 billion different addresses. So in 1983, that seemed like a lot. No problem at all, this will last forever. But of course, these days we have billions of people on the internet and more billions of devices, and so we don't actually have enough IPv4 addresses to do that. We can't allocate a unique address to every device. It's not possible anymore. So effectively, IPv4 is exhausted. There's no more addresses needed, and no more addresses available, and something else is needed. So this was actually known. It was known that this would happen by about sometime in the early 1990s, and so it was way back then that IPv6, version 6 of the Internet Protocol, was developed specifically and mostly to give more address space. So instead of being a 32-bit, 32-digit binary digit number, it's a 128-digit number, which gives 340 billion addresses, which is enough to last the internet, we think, for a long time. We might be proven wrong sometime in future, but at this stage it looks like enough addresses to last effectively forever. Now, so IPv6 has been available for a long time, and it's not yet being used, and I'd like to discuss why not, but perhaps I'll leave that for a bit later in the discussion. You might ask how the internet is still running, though, if IPv4 has been exhausted, and that's because we're using various different technical techniques on the internet to share addresses between collections of devices. So if you're at home and you've got a wireless hub in your house, then that's actually performing, it's not only connecting you, but it's performing the role of what's called a NAT, a network address translator, and it allows the sharing of a single address amongst multiple devices. Now that's all very well and it works well, but there are limitations to the way that can keep on being used more and more throughout the internet. So if the internet was to grow for another 10 years and we were relying on this network address translation system, then the internet would be much less efficient than it is today. It would become more complicated. We would lose that critical factor that we started the internet with, which is the ability to connect any one point to any other point. So the final justification then, the key reason for IPv6 is precisely so that we can go on growing the internet for decades to come while restoring that model that allows every point on the internet to connect to every other point on the internet. It's referred to restoring the original internet model. So I'll leave it at that. That's the motivation for IPv6, and there's plenty more to be discussed about how we're doing it, whether we're doing it, when we'll do it, etc., etc. Thanks, Izumi.
Thank you very much, Paul. I think that was very comprehensive and good opening for understanding why we need to, why we want to encourage v6 deployment. So if for the internet to keep growing in the way we do to maintain the nature of the internet, it's important that we encourage v6 deployment. So the next, I'd like to see if people have 1 or 2 questions or comments, and if you have any questions or comments on this introduction, please raise your hands. And you would also have other, later opportunity to join the discussions as well. Then I'd like to move to Professor Tseng, and he will be sharing the statistics and the measurement on the general deployment, both globally, regionally, and perhaps pick up some of the notable economies on deployment rate. Oh, thank you.
Good afternoon, everyone. It's my great pleasure to be able to talk about the current status of IPv6 readiness measurement. 3 years ago, I initiated the IPv6 readiness measurement board in the APNIC 36 conference. And up to now, there are 30 presentations. And as I know, almost all of them introduce the current status of the IPv6 deployment in a country, an organization, or a region. but with different kind of the measuring criteria. So among all the different kind of measuring criteria, there are three common criteria. And the first one is the IPv6 allocation and the BGP advertisement. And the second one is the service availability, and the third one is the user availability. And according to the RIPE NCC survey, as you can see in this graph, the BGP advertisement is growing steadily all over the world. Yeah. We can find the average, the worldwide average is about 26%. Let's drill down into the data. As you can see, in Asia Pacific region, Japan, Taiwan, Singapore are all above 40%. And Malaysia, New Zealand, Hong Kong, Thailand are above 30%. So next, let me briefly introduce the service availability. The service availability usually include web service availability, email service availability, and DNS service availability. So at this moment, let me take the example, take the web service availability as an example. So as you can see in this figure, the average of the web service availability of the Alexa top 1 billion websites is about 5.8%. It is quite low, it's quite very low. It means that most of the internet content providers fall behind to provide the IPv6 accessibility. So let's take a look at the Asia Pacific region. So Hong Kong, Singapore, Thailand, Indonesia, India, and Taiwan are above the average. So let's take a look at this figure. If we choose the fixed data size, fixed the sample size, for example, such as 500, so this column is 500. So you can find the service availability, the web service availability are getting higher. Every country for the 500 is higher than the 1 billion Alexa websites. So it means the more popular the website, the more the IPv6 accessibility. So let me show you the user availability. So it is very hard to measure the user availability, but it can be estimated by calculating the users who can access the popular and the famous websites. For example, Google, YouTube, Facebook, okay, over the IPv6. So as you can see in this graph, the Google user availability has 1% growth, 1% increase every 3 months in last year. So up to now, the average number of the user availability is over 12%. Okay, so let's take a look of the leaderboard. As you can see in this table, most of the European countries, United States, and Japan are in the leaderboard. So, but the Google as well as APNIC also provide the user availability statistics. But APNIC use a different way. APNIC use the data preprocessing method to eliminate the outlier. So they get a weighted average. The weighted average, which is almost half of the Google index. Okay. Let's take a look at the Asia Pacific region. according to the APNIC user availability statistics, as you can see, Japan, Malaysia, Singapore, Australia are above the average. So that's the end. There's 3 different kind of the common IPv6 readiness measurement criteria. Thank you very much. Thank you.
Thank you very much, Professor Tseng. I think that really gave us a general picture of V6 readiness per service, as well as comparison with like the overall global and some of the notable economies in the world, within the region, how we're doing compared to the rest of the world. So I think it was actually personally quite encouraging, more than I thought, especially to know that if you actually break down to top 500, the bigger websites with user accessibility, then more ready it is. So that would be quite efficient in terms of like the number of users being able to view V6 website. Maybe I'll open up for 1 or 2 questions again before I move to another speaker on this presentation, if anybody has anything to say. Any comments or questions, observations? If not, again, I think you can actually come back later when we have the open general Q&A sessions. So I'd like to move now for individual case studies per different countries. So we have a speaker from India, Japan, and Korea. So first, from India, Rajesh will be sharing the situation in India.
Thank you, Izumi. India. We are a growing country. And after the change of government 2 years back, the government has got a lot of targets, and to fulfill that target, they are laying the infrastructure. We have got the target of 600 million broadband connection on the fiber to the India by end of 2020. And 250,000 villages has to be connected with the optical fiber network. These all figures can be achieved only when we will be converting ourselves, or we will be doing the dual stack of the IPv4 and IPv6, because IPv4 is not there, and buying from the market and using into the network is not going to make a business case of that. Izumi, you asked one question, why IPv6? The question is, now there is no IPv4 yet. And if you want to grow, and if you want that your country should grow with the broadband penetration, you have to convert to your IPv6. Also, the security monitoring agencies are also finding problem in the developing country like India to monitor individual users, and if the service provider has the capacity of taking the port number of each and every individual by netting, doing the netting on the IPv4, that's up to them, but IPv6 is compulsory. In future also, when each of your device, whether it's microwave oven, fridge, AC, will be on the network, and if you want to enjoy the cool room with the hot food, you require individual IP address, IPv6 solution. The problem in India right now, presently what we are facing, while the service providers are ready with their network, the encouragement is not coming from the user side, as well as the government is little idle, I will say, presently. In spite, the government has come out with the roadmap number 1 and 2, and so on they will go. But till the time practically they will not convert all their application, all their server to IPv6, the requirement from the user will not come. And if once the government mandate that banking site, Indian railway site, airline site, and the payment gateway sites are to be converted to the IPv6 or dual stack of IPv4 and IPv6, automatically we will find that the penetration of IPv6 will start a lot. In a democratic country, mandating anything is very impossible, and that too into a democratic country of India. Apart from that, from the user side, lifeline of our equipment is very long. We are using the equipment till the last breath of the equipment. We believe into the maintenance, and when the maintenance guy says that now it is impossible to repair this equipment, then only we change. India has got 65% rural population, and there is a cycle of the equipment. The equipment starts from the metro city, go to the tier 2, tier 3 city, and then the same equipment finally goes to the rural country. That's why the IPv4 cannot be immediately converted to the IPv6 on a fly, because the whole cycle has to change, and when whole cycle will get changed, automatically the things will get better. Digital India, Make in India, Skill India is in way, and under this program, when we will be achieving towards the 600 million broadband connection, we will be able to get these things. One good thing from the government side is coming, that the smart city project, they are trying to mandate into the IPv6, because this will be an application into the city. 100 smart city has already been adopted, and the government is on way to deploy the smart city project into those 100 cities. And this is the good thing which is coming from the government side, that they are mandating that the smart city will be under the IPv6 project. Apart from that, 2017 is the deadline for all the websites of government, whether it's the e-gov application or the service application, all the website has to be converted mandatorily on the dual stack IPv4 and IPv6. And same way is with the mandation to the service provider, that from 1st January 2017, you will not allocate IPv4, you will allocate only IPv6, and to the present customer, we have to give the dual stack of IPv4 and IPv6, so that they should also start using IPv6. This is the story, but one I will say not better, mobile network of India is so complicated that till the time the mobile network is not getting converted to the IPv6, we will not be able to see the good things into IPv6. We are the largest mobile network, and we have got one of the largest mobile users into our system, and most of the people are now using the smartphone. Still, some are using the old technology smartphone, which is not compatible with the IPv6. But yeah, slowly, the user perception is changing, and they are coming to the smartphone and the new smartphone. And we hope once the user will be getting ready with the IPv6, the service provider will be forced to convert their network fully to the IPv6. That's the story of India.
Rajesh, it was actually the first time I heard the situation in India to this level of detail. So I think you've been really helpful in summarizing the motivation behind it. I think there was a point that Paul mentioned that, okay, NATing instead of IPv6 is actually an existing possible solution, but then there are issues surrounded about how do you actually identify user for law enforcement agencies when it comes to NATing, or when there's large needs to assign IP address for Internet of Things. Maybe IPv4 may not be able to accommodate it. And I think you've really listed a good balance of challenges as well as a way forward, in the fact that, well, there are no strong needs for the users, but then you also want to be respectful of the business needs. And then I think you've raised a very interesting point that that may be I don't know if it's only unique to India, but certainly not the case that I've heard in Japan, where the equipment gets like recycled. So once you use it in like big cities, and it gets redistributed to like rural areas. So even if the cities get upgraded to equipment that's V6 ready, then maybe in urban areas, instead of buying a new equipment, people will be using the legacy V4 based equipment. I think that's an interesting challenge that that you face. I think mobile is another area that's a common challenge. Not just in India, and I believe Billy will be sharing a case of SK Telecom in Korea later. Smart city project, that's another interesting thing. I think one of the European cities that has V6 deployment, I can't remember whether that was Belgium or some other city, but they really have high rate of V6 deployment, and I think that's one of the countries that actually have the V6 for the smart city project. So thank you for many insightful information. I'd like to see again if people have any comments or questions from Rajesh's intervention. Any questions or comments from the panelists are also welcome as well if you have any. Anyone?
I'm Rohan from Sri Lanka. Actually, we have a task force established in Sri Lanka to check the readiness of ISPs on IPv6. It is under the Telecommunication Regulatory Commission, and as I work for Sri Lanka, sir, and we are part of that task force. So what we found was most of our ISPs are ready to deploy the IPv6, but the problem is the customer premises equipment CPs. So they are not ready to deploy and provide the service to the customers. So for the ISP point of view, they don't have budget to replace all the customer premises equipment which is compatible with IPv6. So that is the currently prevailing issue. But I think in future they will spend money to buy new customer premises equipment, and it will be increasingly deploying IPv6 in Sri Lanka.
Oh, thank you so much. I also didn't know this the readiness situation in Sri Lanka, so that was really interesting to hear. And the issue with your infrastructure is ready, but customer CPE is not ready. Is I think not just the case in Sri Lanka. So maybe I think Paul.
Everywhere.
Yes, exactly. Paul?
I think the thing to bear in mind though is that the internet is growing. We hear all the time that there are new users coming on all the time. I mean, this is what life is on the internet. It doesn't stay the same. So the question is, what is the equipment that's being installed? Because there's a lot of new equipment being installed. It's not so it may not just be the CPE, but it will also be the equipment that serves the CPE, and that's clear. But the point is that whether it's new users coming on or upgrades to services and so on, this is happening quite often. Services being upgraded. We're going from ADSL to fibre in many cases. What needs to happen is enough advanced planning by the ISPs to actually know that when time comes to do an upgrade, they're going to make sure it's IPv6 compatible. And I saw a brilliant example of this just last week in Vietnam, where the overall deployment rate has reached 1% in a very quick jump, and it came from one service provider decided that they would start deploying IPv6 cable connections for their new cable connections, and they've gone to the extent of 80,000 connections. They've stopped right there for the time being because they're testing and making sure that it works. But it was a very good example that just by simply making the plan, doing it in a staged way, and with that testing, because you don't want to assume that everything's going to work, particularly not when you're delivering customer services to end users. It was a very good example that shows very clearly on the APNIC stats that you've got a jump that contributed to Vietnam's deployment now going to 1% because this particular ISP has got 5% of it. So 80,000 customers they're pushing, they're pulling 25 gigabits of traffic on IPv6 from the major service providers from Google and Facebook. So they're right now in the process of just making sure that's all working before they keep rolling it out. It's just a very good case example of a deployment in progress being done in a way that's working very well.
Thank you, Paul. I think that was good to hear a successful case within our region, and I understood your point that by planning it well, you can actually make this happen, and maybe the new people who are actually joining this initiative has more advantage of it, because you can actually plan it well in advance in steps in more structured way. So thank you very much. That was something that we can all keep in mind. Let's see if anybody else has any comments around this. If not, let's move to the presentation from Mr. Akagawa from the Ministry of Information and Internal Affairs and Communications, the MIC from Japan.
Hello, I'm Tatsuya Akagawa from Ministry of Internal Affairs and Communications of Japan. I will talk about IPv6 deployment in Japan and our efforts as an example of the role of government. First, why does the Japanese government promote IPv6? Key point is, of course, the development of the Internet. The Internet is now the foundation of daily life and industries. So, development of the Internet leads to improved convenience in daily life for our nation, and development of the industries in Japan as a whole. There are fundamental policy goals for government. IPv4 address exhaustion is a barrier to the development of the Internet. This is the basic idea of why we promote IPv6. Please show next slide. This is the MIC's action for IPv6 deployment. MIC established a study group in 2009 to consider the measures for promoting IPv6. About the member, various players participate in the group, such as carriers, internet service providers, network equipment vendors, corporate users, academic experts, and so on. This study group has contributed IPv6 deployment in Japan to discussing the solution to some issues and developing action plans. The study group releasing the report 4 times. MIC has been publicizing the importance of IPv6 actively. And the study group also conducts follow-up the report by interviewing of each player, such as carriers, about implementation status or reviewing action plans and discussing new issues. These results are published as a progress report. This follow-up process is important in ensuring the effectiveness of the report, because if there are some remaining issues, it was discussed among participants on how they could be addressed. It will be a motivation for players to make progress. So I will introduce the point of latest report of the study group. MIC published the fourth report in January 2016. One of the basic thinking is IoT, Internet of Things. We recognize the role of IPv6 is changing from a measure against IPv4 exhaustion to indispensable use to the IoT era. And in IoT era, mobile communication has an important role in directly connecting these devices. But mobile network operators have mostly not deployed IPv6 in Japan. So we decided to include achieving a situation where IPv6 is provided by default to smartphone users with no additional burden by 2017. Mobile operators express their intention in the process of discussion at the study group. And continuing follow-up is also important. At the end of my speech, I'd like to summarize the role and involvement of the Japanese government for IPv6 deployment. There are other industry-initiated activities in Japan. Of course, the IPv6 deployment should be private sector driven because it is a management issue for each company. Japanese government have a mind to support their private sector's activities. So we consider any activities which have synergies with such activities. Concretely speaking, for example, awareness raising to key stakeholders through the study report, or facilitating a place for discussions among various key industry players at meetings to follow up from the report, and other activities which are challenging to conduct in private sector. That's all. Thank you.
Thank you very much, Mr. Akagawa. I think this actually, you touched upon a couple of points that was also mentioned by Rajesh. So I think Rajesh mentioned that it's a bit difficult for governments to regulate things, being a democratic country. But so I think it's the Japanese government is taking basically, based on this this policy that you don't force or regulate the users, and you tolerate the initiatives by private sectors. But the government played the role of a place for facilitating discussions, and then they produced a report. And what's interesting about the case of Japan is that they don't just produce the report, they actually do the follow-up to confirm, gather stakeholders to see the progress. And if there's a particular stakeholder that is not making a progress, you discuss among everybody what the issue is, and if there's anything that other stakeholders can do. So that actually, helped in providing an environment that would consider a way forward as all together, as well as I think it's a bit of a peer pressure that if you don't actually address your own part, then it's a bit embarrassing. I don't know if it works in all cultures, but it certainly worked in Japan, as you can see from the rate of deployment. Another thing that I thought was interesting was, so after producing the report, and I think there's really high rate of deployment by access line providers, the government now produced the next step report focusing on the IoT and mobile, and that I think as a result of the report, the mobile phone providers have actually, I don't know, the word agreed would be too strong or not, but I think they're conscious and have basically, willing to move forward to have all the users, their smartphone subscribers to be ready, V6 ready by 2017. So let's see how things will go on this collaborative measure and the progress after this report is published. And I think this really provides a good segue to the next speaker, Billy. But before I go, let's see if people have any questions or comments about Mr. Akagawa's presentation.
I think that in Japan, you have successfully deployed IPv6, and you may have practical experience running it for past few years. So have you found any IPv6 specific security issues, and how did you overcome them?
Very good question. So he will explain in Japanese, so I can translate. So based on the research by the Japanese government, they consider there is actually no IPv6 specific security issue. So there are common security issues for both v4 and v6, but there's no fundamental big security issue that is caused by IPv6. And of course, there are some products that is not ready in IPv6 in certain security features, but many of the products are today IPv6 ready, and so they don't think that certain products not being ready for IPv6 for security, it will be a big enough barrier for deployment. And I think the Japanese, just switching my hat to as someone from Japan, I think the Japanese government also provided some experiments and published a report on security testing for IPv6 in collaboration with a public sector, and this is published on the website. Maybe it's only in Japanese. Is it available? Okay, unfortunately it's only in Japanese, but I don't know, maybe you can use a Google translation or something. So if you're interested, please feel free to reach out to Mr. Nakagawa. Myself, we can share the URL, and maybe you can translate it in English or your own language. So that was a very good question. Thank you. Anyone else? If not, then let's go to Billy. Billy Cheon from KISA.
Thank you, Izumi. My name is Billy with the Korea Internet and Security Agency. We are working with very closely with the Korean government. I'm SIP in the area of internet promotion and information security, and also IPv6 is a part, one of the important issues we're following up. So I'm here to share general pictures where we are standing in terms of IPv6, and also we attended a RIPE NCC meeting, and we met major ISPs from European region, and we did some comparative research, and I want to share the findings that that is important to share with you. So. First, let me tell you a little bit about general picture of our status, basic status. V6 was introduced in 1995, and we started early, actually, relatively early. The first IPv6 allocation to Korea was made in 1999. It's for research network, and currently Korea has a fairly good amount of IPv6 address. We have more than about 5,000/32 addresses, which is quite enough for next generations, I believe. And however, in terms of actual usage, we have kept quite a low profile. Regardless, our multifaceted efforts to deploy IPv6 for the last years. And this morning, I checked Google website and IPv6 usage website, and it shows Korea it turned out the result Korea's usage is 3.58%, which is not much figure, but in terms of IPv6, I think it tells we just take off fly. And also one thing notable is that we can find I can find the surge of IPv6 usage in 2014. So let me. So here I want to tell you more about what has been done, what was our effort behind these figures. From first the public sector, the Korean government and KISA, we set up a 3-year plan to support IPv6 transition at national scale. And as other government does, the Korean government made, from policy side, we also made all government ministries procure IPv6 compatible equipments by law since 2014. And also the government exempted the income and corporate tax in IPv6 equipment purchase. That's 3% for large companies and 7% for SMEs. And also we are recommending ISPs and CSPs to deploy IPv6 on their commercial services, while we just focused on changing IPv4 legacy equipments to IPv6 compatible equipments. We're trying to more practical these days. And Korea, KISA is also operating IPv6 deployment support center since 2014. Through this center, KISA is providing a help desk service and trainings, and also testbed for IPv6 transition. Especially with the testbed, we are planning to upgrade the testbed to the level of where security vulnerabilities can be tested. And we also host IPv6 workshops and also publish guidelines to share technical and managerial know-hows. This is highlighted things that has made from public sector. And now I would like to tell you a little bit more about private sector. Like Izumi mentioned, in the mobile, SKT, that's the first ISP which deployed IPv6 on their commercial services. They deployed IPv6 on the voice and data of commercial LTE networks in September 2014. Followed by this, in December through collaboration with KISA and major CATV operators such as CJ Hellovision and CNN and HCN also deployed IPv6 on their commercial services. And this year, Naver also commenced the IPv6 applied commercial services. Now, IPv6 services are being provided for 11 regions with about 60,000 subscribers in Korea. And I think, hope this explains certain IPv6 traffics on Google website for Korea, and gives some general pictures of where we are standing. And I also have some maybe interesting or you already knows findings from interview with the European ISP. So should I go or should I save this for discussion later on?
I think that's a very great way to move on to the discussions, which I was planning to do for the Q&A on observation on the successful cases and unsuccessful cases, and what would be the any trend that you observe. So I think that would be excellent if you can share. But before you go, maybe people have questions to what Billy has shared so far. Any comments or observation about the situation in Korea. Thank you, Billy, for sharing both the public and private sector initiatives. So I think we have a question from the floor. Can anyone pass the microphone?
Hi, hello. I'm Tomohiro Funisaki from the NTT1 Japanese telecom operator, and just want to ask you about the security of the mobile. So, in Japan case, in the wired ISP, CPE has a firewall function and block the attack to the devices. But in the mobile case, the smartphone will be connected directly to the internet. So in the SK Telecom case, how the security is, how secure their devices? Is there any firewall or something like that in the network? Or I just want to ask the security about the mobile device.
That's the question I don't want to get because I'm policy side. I don't have such expertise in technical area. But like I said, KISA is operating test bed, and I think there we study on those problems. But I cannot give you details. I mean, cannot give detailed explanation for that.
Okay, so if you have any information, please let me know.
Yes. I will probably let you know the right contact for that. Yes.
Yeah, thank you so much.
Thank you for the question. I think that was an interesting observation that there may be additional security consideration needed on the end user connection side compared to connection with the CPE, because users will be using their smartphone, mobile to connect to the V6 internet, which may not have the same functionality as the CPE. So yeah, I think it would be useful if, well, it might be a bit sensitive, but individually can share know-how that might be very helpful. So thank you for this question. Yeah, I think it was interesting how Neighbor, that's a big application service provider.
Yes, content provider.
Oh, content provider.
First, in the terms of size, yes. First, content provider.
Okay, yeah. So we hear a lot from the global players that their contents are V6 ready, but I don't hear much from localized content service providers that they are V6 ready. So I think it would be, that's an interesting case to share. And I think if this something can be shared for the global IGF best practices, I think that would be like a case, good example case for others, not just within the region, but then globally as well, if they don't mind sharing the motivation behind it. So thank you, Billy. And so if there are no other comments or questions, I think we can move to the discussions part, where I'd like to have discussions with everybody here, not just the panelists, on from the presentations or from your own experience and observations, do you see any commonalities in trend on the successful or unsuccessful cases in V6 deployment? What do you see as the remaining challenges, and how can we address them? I think some of them have been already touched through the Q&As. And what are the roles that different stakeholders can play? So I think, sorry, did you want to make a comment? I'll go to you, Billy, for sure.
Okay, thank you very much for the very informative presentation. This is Zakir. I am from a country which is not having very good statistics in terms of IPv6. Yes, Pakistan, PAL. You see, it is very interesting. But interestingly, when you are sitting in a forum in Taipei that is all about IPv6, and you all of a sudden you see you yourself are not an IPv6 network. I just did the test and we are on as we just saw that, I mean, the commonalities about and the trends about IPv6 deployments, and certain parts of the world are not doing very good in terms of IPv6 deployment. What I have seen in my observation is that probably is because the end user is least interested in if he or she is on IPv6 or IPv4, because what they need is good, fast and reliable internet connectivity. So probably that is one of the major reason of the slow deployment in countries like India, Pakistan or Bangladesh, and on top of that the equipment as well. I mean, I've been in the working in the telecommunications industry, and there is a similar problem in telecom deployment or internet deployment or access as well. I mean, there have been operators using access technologies like CDMA or WiMAX or ADSL or you see GSM or 3G or 4G or LTE. What the end user needs is fast and high and speedy bandwidth, and they don't care if it's CDMA 450 or if it is WiMAX or ADSL, right? So I mean, there are international regulations and restrictions from institutions like ITU that, I mean, countries actually have to utilize some certain funds which they call universal services obligations, which are being used for deploying telecommunication networks in the rural and remote areas, so as to make sure that everybody gets equal access to internet. So do you feel the need for such an initiative? Maybe probably Paul can comment on this. The need for such an initiative that I mean, governments or organizations like APNIC should give rise to such an initiative whereby funds like USOs are utilized, I mean, specified, and governments and regulatory bodies ensure, I mean, that ISPs should contribute to these funds, and then those funds should be used for deploying IPv6 in these markets. Because in majority of the markets across the globe, the internet industries with the private sector, and their eyes are always on their return on investment and their economies of scale and stuff like that. So I mean, they don't see literally, they don't see any financial gain after moving to IPv6 financial gain, right? But they are always reluctant to investing on infrastructure on IPv6 and stuff like that. So funds like USOs might be contribute to a shoot on the IPv6 numbers. Plus, as Rajesh was mentioning, 600 million target of broadband. I mean, that's huge, almost twice the population of United States. So if we probably are able to, having at least 50% of these new broadband connection in India on IPv6, so that will be, an exponential growth in IPv6 numbers. So might be these things can be, tackled from policy and regulatory point of view more than talking directly to the end user or to the network owner.
Rajesh sir very rightly pointed out that the customer needs the fast internet and reliable internet. But at the same time, the customer needs a lot of new applications also. And when they will be seeking the new application, automatically sometime they have to change. Like earlier we were using the feature phone. The moment smartphone came, we adopted the smartphone because the smartphone was very close to our lifeline. The same way, IPv4 will require to be changed to the IPv6 when at your home you will be putting lot of devices and you will be demanding from the service provider that I want the IP address for those devices to run, and that to a real IP address, no netting. Then automatically you have to change your CPE at that time. You cannot rely on the service provider only that he or she should invest into the network of the CPE also. Because my duty is to provide you the internet, and if you want to use internet for your daily life, for your all the devices, then you have to invest from your side also. So this is the thing. Regarding the penetration, I already told that we don't have any IPv4 and the new network is coming, and 600 million broadband can be achieved only on the IPv6, not on IPv4 at all, because our law enforcement agency is very clear that now 2017 onwards, they want the IP detailed record of every user. And if you will be doing netting, then it will be a responsibility of the service provider to provide the port of each and every individual. I don't think we are able to do that.
Could I just answer in terms of what governments are doing? I think we should be very cautious about asking governments to specify technology. I think we might regret that down the track as a general principle. But I think it's important to link, and has been important to link IPv6 as a special case with other governmental programs and visions. So, for instance, in APNIC's work with APEC Tel, we found that some years ago, APEC Tel had adopted a grand vision for broadband deployment throughout APEC countries. They wanted to have kind of comprehensive broadband deployment by about now, actually. And we found it was a good way to link to that, to say that, and to convince that that was not going to happen without certain things being in place, and we successfully had IPv6 adopted as one of the conditions that they were going to promote as a very special case, as an enabler for that vision. But it was really, I think, very important to link the technology to the vision, which is what the governments should be setting, the policy and the direction for the future. And that was one case where I think we successfully were able to do that. What I understood from a visit to Vietnam last week was the government has taken a carrot approach and not a stick approach, and they're one case where right now there actually are tax incentives for IPv6, in that IPv6 has been categorized as being a member of one class of special technologies that receive, beneficial treatment or beneficial treatment in a tax sense. So there's a relief of VAT and a relief of import tax for certain classes of technology, and IPv6 has been adopted as part of that. So again, it's a case of having IPv6 recognised within some existing government program, and I think that becomes quite feasible as a policy move then. Thanks.
The speaker from Thailand, and then afterwards we go to you, Kenny.
Yes, Vanawit Akabut from Thailand. I speak on the capacity of the GACS rideshare. Just to update, during the policy forums in Helsinki, ICANN 56, ESAC, who ESAC is the Security and Stability Advisor of ICANN, come to GAC. If you're interested, you can search the words like SAC 79. It's the paper related to the nature of changing IPv6. It provides a very good executive summary. So I think they brief the government what are the implications if you let the industry decide whether they go V6 or not. They raise the three simple things for the government that don't know anything. I agree with Paul, but they raise the public concern. For example, on the application designer, problems that we create if we not go to the V6. The law enforcement and forensics that you already mentioned is the concern for the government too. The last one is the data retention policy. We create a huge cost that finally push back to the end user. They give a very good advice on advisory points and provide recommendation. I'm responsible for making the report back to 184 countries we have to coming up with a recommend public policy standpoints that whether how GAC react to this. So there's some movement on the government to help the industry, and it seems to me that I'm trying to find the financial justification for them to go on, or you have to use this kind of peer to control. But I do see there might need to have a public policy standpoint for every government, which direction we will go for V6, and I'll keep you updated. Thanks that you invite me to the IPv6 group already. I will keep update through that working group. Thank you.
Thank you very much for sharing this update and what you see from the GAG perspective. I think that was interesting, and I think we see a commonality that the point that Rajesh mentioned, and I think earlier Paul as well, about netting, that it would be challenging and would impose additional cost by having a system that you need to keep record of who the user was by adopting the netting. So you might think V6 costs, but then netting might also cost as well. So let's go to Kenny.
Yes, just Kenny Huang, Executive Council member of APNIC. Just clarify, because as a local committee, suppose we is quite shame without running the conference here without IPv6, because the network was sponsored by local carrier, and that's why explain they have difficulty to provision IPv6 service within such a short period of time. That's why envision, and they mentioned, they explain the result. And also I checked the Google website, and up to today, the Google IPv6 adoption in Taiwan is only 0.29, so it's quite a shame. So that probably explains because the local carrier, they are reluctant to provision that kind of service. That's why we only have IPv4 today. And the other excuse, I just realized, the recent key application, Pokemon Go, and it doesn't support IPv6 well. So in the official website, he recommends all the users turn off their S and switch from IPv6 to IPv4. So I assume you can play the Pokemon Go very well here. Thank you.
Thank you, Kenny, for sharing the situation and the background behind the network here locally. I want to add really quick point. From about the speaker, the observation which was made that the end user actually don't care whether they're using V6 or V4, and they just care about the stability of the internet, the speed. I think this is very true. And in case of Japan, what ISPs have decided is that they don't let the end users care what, so they don't need to subscribe, we want V6 network or not. It's going to be the ISP side that they will have all the end users ready as default. And they made that decision because it's for their service benefit, for the long-term sustainability of their service, for user growth, as well as I think some of the cost factors being mentioned about additional cost in netting to keep the record, as well as if you update the equipment, then most of the updated equipment are V6 ready. So it's not like, conceptually you might think V6 is additional cost, but you actually can be V6 ready by simply updating your equipment. So that was a quick comment from my perspective from Japan. And then let's go to Billy. Well, actually, there's one question from remote. So sorry for keeping you on, but this is very much in sync with your next comment, Billy. So there's a question from remote. It would be from Roger. It would be interesting to summarize similarities and differences between countries, different countries' V6 strategies, and also opportunities for synergies and cooperation. As a suggestion, perhaps the board can consider an independent subcommittee to address the security concerns. They can study each country's approach to enabling V6, deploying V6, then provide their finding and recommendation to APRGF board. So I think the idea is maybe we share the common practices and observations and share information, including some of the security concerns. So I think that was a good and interesting suggestion. So thank you so much for your patience, Billy. We were very interested to hear your comparison and observation on the European ISPs.
As I explained, we, Korea, and also other countries have a lot of efforts with huge resources, but still struggling with challenging issues in IPv6 transition. I mean, the cost burden for IPv6 transition is still high, especially for SMEs. And also there is a fear and uneasiness against V6 from security perspective. There is merry-go-round between companies in moving to IPv6. I mean, companies shift the responsibility each other. There's no IPv6 content. Infrastructure is not ready for that reason. They are hesitant to move. So, KISA, we try how to to solve this kind of problem, to find a breakthrough. We think it's very important to, just like remote participants said, important to study other cases and try to compare and find the commonalities and difference. So KISA attended LIPE NCC meeting, another region, which is normally we don't. And we had an interview with the major ISPs. So from the interview, I just want to share with you some of the interesting questions and answers. So first thing, first we asked why Europe region is relatively ahead of other regions in terms of IPv6 deployment. They said they have multinational ISPs, which led the market. And so for the region, the market is very competitive. And also in IPv4, CGN, carrier grade network, cause legal problems. And another thing is, if the CTO has a technical background, it's easy to make a decision to deploy IPv6. That's the question and answer. And another thing is that from government, do they have a government IPv6 support, government support in moving to IPv6? And almost, they said they don't have much, almost none. And even there is, they think it's not effective. However, if there's cases like if local government start a smart city project, like a huge, and there if they need IPv6 is needed, then it would be more efficient. So I would, I think probably indirect approach would be needed. And also another thing is that they mentioned is that network operators group NOC activity was very active, lively discussions and sort of volunteering volunteers. They have so many volunteers in terms of NOC activity. And we also asked, is there any benefit from IPv6 deployment? They said no, there's none from short-term view, but there is a very, it was kind of interesting. I mean, one of the interesting answer is that after, one of the ISP answered that after IPv6 complete adoption, they can sell IPv4 at high cost, because this, they said that it's kind of investment, and they said so. And they also, we also asked if there's any difficulties, like additional difficulties with IPv6 network from security perspective and operation. They said, most of them said it's same as IPv4 network. And also another, what is challenge then? We asked, and they said legacy equipment challenge. Changing legacy equipment is a big challenge, especially in the fixed line. CPE equipments are too many, and it's costly to change. And last thing we asked is that what is the main factor to influence on IPv6 measurement index? It's like in Google measurement site, and they said if there's one monolithic ISP which has more than 30% device, and then this ISP allocate IPv6 as default, so then the graph goes up, skyrocketing. So they are from Belgium and Greece. So we concluded that probably we need to encourage to have encourage more discussion in the network operators groups, and also maybe we need some. We should leave more to market. Should be more like a market driven, not government driven. Maybe government, it's time to step back one step and probably support. That's what we found in general. Thank you.
Thank you so much, Billy. I think that was really comprehensive and useful observation. Many of them also matched with the discussions and points being raised here, such as I think, well, like for example, in terms of security, I think you would think that there may be additional security issues in IPv6, but then it's basically the same with IPv4. The issue with legacy equipment, especially on the CPE for end user, I think that's a common issue being shared here as well. I don't know if we can actually think of a way forward rather than keep on growing the network, and as we actually have all the new network, the legacy equipment will no longer exist, and it will not even be a legacy or not. This may be something that if people have any good way around that you found, it would be useful to maybe share the experiences. And I think your final sort of like summary observation that leave it to the market it's very much consistent with the points that Rajesh made, and also with the case of the Japanese government that they leave it to the private sector initiative, and they just play the role of facilitating the discussions. And I think you really raised a new point about the network operators group. They were actually, played a big role in awareness raising and also motivating the technical people. And then they actually also pushed companies to be V6 ready. And that's certainly the case in Japan as well. We have what's called JPNIC with over 500 participants, and we do have active technical communities. So I think this collaboration with this active technical community existing, and then with having a place for discussion, sort of like worked as a synergy. Rajesh, you wanted to make a comment?
Oh yeah, in terms of NOG activity, we interviewed ISPs from Europe and countries with a high IPv6 deployment. They all have the NOG. Like Belgium, they have a BENOG, and Swiss has a SWINOG, Germany DENOG, Greece has a GRNOG. I just wanted to supplement.
Thank you so much. I think that doesn't get too highlighted in this kind of forum, like Internet Governance Forum, but I think that's really good observation. So thank you, Billy, and hopefully this sort of addresses part of the question and suggestion from the remote participant, Roger. So if you have any additional questions, feel free to make a comment on the chat, and thanks very much, Roger, for your input remotely. And let's go to Rajesh.
Izumi, the difference between the Europe and the Asian Pacific is, first of all, the purchasing power of the European country and the population. That's why their percentage grows like this. But if we compare it with the population of our region, then we are also growing, but our percentage is not being visible so clearly. So if we compare both the things, still Asian Pacific countries are doing very fine.
I think that's a fair and a good observation. That, and then I think that's also in line with the point that Billy made. Maybe some of the countries, they have a large. I mean, maybe the country itself is relatively like small in population compared to some of the countries or economies in the Asia Pacific. And then if like a big ISP becomes V6 ready, then it really, V6 takes up. Whereas, in big countries in Asia, maybe there's more competition, and it's not just simple as like one ISP adopting V6 and then the V6 deployment rate raises. So it would be good if we can compare like regional differences, and it's certainly something that V6 Best Practices Forum this year would like to analyze and make observations. And I really encourage those of you here to provide your contribution to this global forum as well from the Asian perspective. And I think you raised an interesting point about the smart city. So that might also, having governments having smart city to be V6 ready, that might be a drive for encouraging V6 deployment and matches with the situation in, did you say Belgium? But, well, one of the European countries in any case. So thank you so much. I think we have a question or comment from the floor.
So I'm Jerry I'm a local college student from Taiwan. And I want to talk about why the readiness rate and adoption rate of IPv6 has a huge gap. Like we have 40% of readiness, but we only have, like just he stated, 0.3% of deployment rate. That's because unlike many Asian Pacific countries, Taiwan's ISP actually provided the CPE devices like in our homes. So they provided the cable modems and fiber modems to houses. So basically, most recently installed internet, like in the recent 5 years, their CPE is already IPv6 enabled. But they did not apply for the IPv6 service. I tried to, as a home user, I tried to apply for IPv6 dual stacking at the first place, like 2 or 3 years ago. But, however, the transition cost was very huge. It takes, I used to have a stated IPv4 address that needs to be taken away from me for a week because of the transition. They need to come to my house to change the CPE devices. And after that, after like a week or so, I finally been enabled for IPv6. But even so, they did not configure my CPE devices to actually get IPv6 addresses. I need to configure it using manually by myself. So that is why IPv6 adoption rate is so low in Taiwan. It's hard to apply, hard to configure, and hard to set up. And for academia, I study in a national university. I won't state the name here, but we cannot apply for IPv6 addresses in dormitories, and labs, even though we have a /40 prefix for our school. So that's why the adoption rate is so low. And I also have a question for Mr. Tseng. What are the government going to do, like to improve the adoption rate, like to spread it more to the normal customers, like on the CHT or what? And also, the biggest ISP in Taiwan, the Chunghwa Telecom, their DNS service is still not IPv6 enabled. But that's what most people use by default in Taiwan nowadays. Thank you.
Thank you for sharing the real-life experience from the local country, Taiwan. So,
yes, this is a very important question. So everybody wants to know the reason why. So, me too. And as you may know, in Taiwan there are 3 different kinds of the ISP. The first one is Taiwan Academic Network. This is for all the schools. And the second one is a commercial ISP, it's a commercial internet services. And the third one is a government service network. So if you can take a look at the top 10 adopter of the IPv6, you can find that almost all of the top 10 are academic, from academic. So that's the reason why you cannot, it's not easy to get a IPv6 service from commercial. So I'd like to mention at this moment it is a summer vacation. So summer vacation, the IPv6 user availability is very low because the school, the dormitory, most of the dormitory are closed. So that's the reason why. If you take a look at the maybe the March, April, then maybe higher, maybe point. Maybe as I remember, maybe 0.8, okay, close to 1.0, something like that. I like to mention for the government. I like to share the story with you. So 4 years ago, the TWNIC proposed government IPv6 deployment proposal to the Ministry of the Transportation and Communication. But this project basically is a 4-year project with no extra budget. Okay, no extra budget. Okay, so in the last 4 years, all of the 4,500 governmental agencies, okay, departments, all of the central government, the local government departments, all have been upgraded to be IPv6 capable. But this project only can raise the service availability, web service availability, not related to the user availability. So the user availability, the key is the commercial ISP. So therefore, 1 year ago, so TWNIC has established the working task force. This task force is composed of the commercial ISP, and especially the most important thing is the chair is the president of the HiNet. So I expect this task force. Okay, as mentioned, Mr. Ma is the president of HiNet. 2 days ago, he said Chunghwa Telecom will introduce the mobile service, mobile IPv6, maybe by the end of this year. So I expect this big breakthrough, okay, to provide the IPv6 services for the mobile user. Okay, but as you may know, in Taiwan there's an iTaiwan project. iTaiwan project is a lot of the hotspots across all the island, more than maybe 1 million. Okay, I don't know. So it's a huge number of hotspots. So our goal is to upgrade this hotspot to be IPv6 capable. Okay, maybe by the next year. So this approach can raise the user's availability. So I'm also want to encourage. Okay, the point is how to encourage the commercial ISP, the network operator, to deploy, to upgrade their services to be IPv6 capable. Okay.
Thank you very much. I think it was really good to hear the question from the local and then hearing what's being done locally here in Taiwan. And we are actually running short of time. So did you want to make
three sentences?
Yeah, sure.
Actually, every household have fiber to their building or fiber to their house has already be IPv6 readiness, but it's hard to get IPv6 enabled. Mm-hmm. So the ISP has already done the part. It's just that they didn't advertise that you cannot apply for IPv6, and it's hard to apply for it.
Yeah, I understood your point very well. So even though like service-wise, infrastructure-wise, it's ready, but then it's very complicated and difficult for users to apply to IPv6, is your point, right? So I think this may be something that, you know, ISP, I think Paul has mentioned that like pre-planning and strategically might actually help a lot in deployment, and it might be something that ISPs in different parts of the world can actually keep a note that, it's not just technically, but then procedurally applying for service, make it easier for people, users to apply without too many hurdles, or like, even make it a default without users having to apply to it. That might be something that, ISPs can consider. So I think we're actually running to the close to the hour, but okay, let's go to one more person from the floor. And then I'd like to wrap up with possibly, if like any of the panelists wants to have like one last word, then I open this up and then we'll close the session. So thank you.
Okay, Gunda Chai from JPNIC. As I know, the DNS server from HiNet is dual stack ready and enabled. So you can check the DNS.HiNet.net. Yeah, it's IPv6 ready.
Okay. Thank you for that piece of information. So there is ISP in Taiwan, HiNet, that is v6 ready, and you can actually check. So is there anybody from the panel who would like to say one last word to wrap it up? Anything that you actually missed to say, or yeah, Paul?
Look, I think there's been a lot of talk about IPv6 for a long, long time, and people still ask why isn't it done yet, and haven't we, or even haven't we found another solution now, as though we don't need it anymore. It's really important to understand that times are changing now because of the exhaustion of IPv4, that v6 is being deployed in huge numbers around the world. There really is no excuse for not deploying it. There's no case for saying it's not secure, it's not ready. The mobile providers in the USA are doing it very rapidly now. The US deployment is advancing very fast. They're now at more than 30% of users in the US. That's more than 100 million users in the US who are using IPv6 today. So for anyone to say, well, we're not ready, or to make excuses really is not, it's not sustainable. It doesn't mean everyone has to deploy it tomorrow or immediately, because these things need planning, as I said, and although it's urgent, it needs to be planned and done correctly. But I just think it's very important for us to understand that this can be done now. We're in a situation now where, frankly, there's a v6 divide in the world, and there are countries which, courtesy of their ISPs not moving, are lagging far behind on v6. And I think, although it is in the hands of the ISPs, there is something to be done here to avoid that v6 divide. It's something that can be done, and we just simply need to be moving and planning, and not to be making sort of excuses or hiding our heads in the sand. But that's all. Thanks.
For words on the direction forward in terms of thinking. And so a word from Mr. Nakagawa, and then we'll close the session.
Yeah, I will comment shortly. Actually, the IPv6, the use of IPv6 is increasing. So, according to the data by Google, as Dr. Tseng mentioned, the percentage of IPv6 is increasing at a rate of 2 times per year. So, even in Japan, it is not enough in IPv6 deployment, especially content side, as the data Dr. Chen mentioned. So we hope the private sector take the initiative to in IPv6 deployment with a conscious of these global trends. So Japanese government would like to support these activities.
Thank you so much.
about the observation about the remaining challenges, the willingness for the government to promote the private sector initiative, and I think that really goes back to the words given by Paul on let's really be conscious and try to move forward with V6 deployment. And thank you so much everyone for joining. I think it was really lively discussions, and just a reminder that this best practices forum at the global IGF on V6. So if you actually go to the IGF website, the global IGF website, best practices forum V6, you can subscribe to the mailing list. Anybody can join, and I welcome contributions from the Asia Pacific region. Thank you so much.